Hey guys, welcome to a new lesson. This is lesson 9.4.1, Systems of Inequalities. In chapter 4, you learned that the solution to a system of equations is a point that makes both equations true. But what about the solution of a system of two inequalities? How can you represent these solutions on a graph? How many solutions can a system of inequalities have? Consider these questions as you learn how to graph a system of inequalities. And just a quick reminder for you, when we're dealing with inequality symbols and graphs of linear inequalities, less than or greater than gives us a dashed or dotted line. It doesn't matter which one. But less than or equal to and greater than or equal to give us a solid line. Okay, so 9-89 says find your graphs for problem 9-84. Here are the two inequalities for this problem. Y is less than or equal to negative x plus 5, and y is greater than 2/3 x minus 1. You did these problems yesterday as part of your work. It was the first problem on that lesson 9.3.2 work PDF. So grab your solutions from yesterday, compare them to these solutions, and what part A wants us to do is to basically just correct any errors. So all I want you to do for part A is to just check your work. Make sure that your graphs resemble mine. They don't have to be shaded in color, but you do need that solid line for the first graph shaded below. Make sure that your slope and your y-intercept are correct. Remember, for y equals mx plus b, b is your y-intercept and m is your slope. And then for the second graph, make sure that your line is dashed or dotted and that you're shading above. Okay. Part B says, what would the graph of the system of inequalities look like? Consider the system of inequalities below. Which points are solutions to the system? That is, which points make both inequalities true? Graph using Desmos. So you'll notice that these are the same inequalities that we have above. This inequality corresponds with this graph, and then this inequality corresponds with this graph. So we know what these inequalities look like when they're graphed separately, but what does it look like when we graph both on the same set of axes? So I have this preloaded Desmos page. Let's see. Here's that first inequality that we graphed. Y is less than or equal to negative x plus 5. What do you think it's going to look like when we add the other graph? That is what it looks like. So we're overlaying essentially both inequalities on top of each other. Okay. That's what that one looks like by itself. That's what this inequality looks like by itself. And when we graph both together, this is what we get. Okay, now where are the solutions? The solutions are where we have overlapping shading. So right here where we have just green, not a solution to the system. Over here where we have just purple, they are not solutions to the system. Over here where we have white, nope. Over here where we have overlap, it looks kind of like a dark purple, like you can't really see the green, but you can see that it's like double shaded. Those are your solutions. So I've copied and pasted that graph. So this right here is what we call the solution region, where there is overlap. Okay, that's why it's important to shade your graph. So please make sure that when you're graphing these inequalities that you're testing points and you're shading appropriately. You don't necessarily need colors or highlighters or markers. You can use your pencil, like shade, I don't know, shade one way and then shade the opposite way, if that makes sense. Make it darker if there's overlap, but our solution region is our overlap. Okay, Part C says, if you have not done so already, verify your solution region from Part B algebraically by substituting the coordinates of a point from your solution region into each inequality. So I know that because 0, 0 is in my solution region, that 0, 0 is a solution to the system. Which means it makes both inequalities true. So let's verify. Here is my first inequality. Y is less than or equal to negative x plus 5. Plug in 0 for x and 0 for y. Okay. 0 and 0. Negative 0 is just 0. And then 0 plus 5 is 5. Is 0 less than or equal to 5? It is. Okay, so good. We're checking and it works. That's what we wanted. Now let's check for the other inequality, which was y is greater than 2/3 x minus 1. Plug in 0 for x and 0 for y. Okay, 2/3 times 0 is 0. 0 minus 1 is negative 1. Is 0 greater than negative 1? It is. Okay, perfect. So it works for both, and that's what we wanted. If you test a point here where you have only green shaded, it'll work for one inequality, but not for the other. Same is true if you test a point here. It'll work for one inequality, but not the other. If you test a point here, it'll work for neither. Okay, here where you have the overlap is where you will have points that make both inequalities true. So where it says here in Part D, how can you be sure that this region is the only set of points that makes both inequalities true? Well, we can just test points in the other regions and verify that they're not going to work. But our conclusion will always be that points in the solution region, okay, the overlap, are the only points that make both inequalities true. And that's what we want. Okay, so let's practice here in 9-90. Draw a graph of the region satisfying both constraints below. Start by graphing the boundary lines and then test points to find the region that makes both inequalities true. So we're going to graph both of these inequalities on the same set of axes. Let's see, let's start with this first one. Y is less than x plus 2. Because it's less than, it's going to be a dashed line. My y-intercept is positive 2, and then my slope is positive 1. So for my slope triangle, I'm going to go up 1 and over 1, and up 1 and over 1. Draw your line. Again, it is going to be dashed or dotted, whatever you prefer. Okay. And then remember that when we graph an inequality, we have to test a point on a side of the boundary line so we know where to shade. So I am going to test 0, 0. since that is a very easy point to test. So I'm going to plug in to my original inequality 0 for x and 0 for y. And simplify. 0 plus 2 is 2. Is 0 less than 2? It is. So 0 is a solution. So I'm going to shade towards 0, 0. That means that I'm going to shade below the line. Let's maybe pick a color lighter than that so you can see it. Okay, there we go. Awesome. Now let's graph the other inequality. This is less than or equal to, so that's going to be a solid line. My y-intercept is 10, so starting at 10, I'm going to draw my slope triangle. My slope is negative 3/4, so that means that for my slope triangle, I'm going down 3 and over 4. Then down 3 and over 4, and connect those points with a solid line. I'm trying to move the ruler, not the whole graph. Okay, there. And there. All right. And now let's test a point to see where we're going to shade. I'm going to test 0, 0 again. So take your inequality. Plug in 0 for x and 0 for y. And simplify. Let's see, 10 minus 0 is just 10. Is 0 less than or equal to 10? It is. That's great. That means that we're going to shade towards 0, 0 for that second inequality. So for this line that I just drew in like dark pink, whatever this color is called, we're going to shade towards 0, 0. So I'm going to take a different color. Okay. Shade, 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 shade. So see how we're getting some overlap here? We're starting to see some purple because we have both pink and blue. That is our solution region. It is a coincidence, a very nice coincidence, that 0, 0 is in our solution region because we were able to test 0, 0 for both lines and figure out that we were shading towards that point for both of them. But any point in the solution region would make both inequalities true. So this point over here, and this point over here, and this one, and that one, and even this one here on this line. Okay, anything in the solution region will work. All right, let's move on to the next problem, 9-91. Looks like we have a quadratic inequality and a linear one. How many regions? When graphing the system of inequalities below, Raina started with the boundary graph of each inequality shown at right. So here is the parabola that corresponds to that inequality. And it's a solid line because of the inequality symbol, less than or equal to. And then here is the, I apologize, my Microsoft stylus is really lagging. But this is the line that goes with that inequality. And it's a dashed line because it's only greater than or equal to. And it looks like I already answered part A. Why is the line dashed while the parabola is not? Okay, this just doesn't want to cooperate with me. Scroll, one note. There we go. Okay, why is the line dashed while the parabola is not? Because of the inequality symbols. I wrote up at the top of this lesson at the beginning of the video that when you have less than or equal to or greater than or equal to, that is a solid line. Less than or greater than is dotted or dashed. Okay, so that's why. Part B says, how many possible solution regions are there? Carefully count each region. So could we have, how many solution regions could we have? Let's see. Well, this could be an overlap region. So that's one possible region. Here's a second possible region. Here's a third possible region. Okay. And these are all just regions where we could possibly have overlap. Okay, here's a fourth, and that'll go around the parabola. So all of this is another possible one. And a fifth one, let's pick a different color. This could also be a possible solution region. Okay, so in all, that's 5 possible solution regions. Those different 5 colors represent those. So 5 possible, here we go, 5 possible solution regions. And again, my Microsoft stylus is acting up. I don't know. I'm speaking and it's writing, but the ink is not showing up until a couple seconds later. So sorry about that. Let's move on. And my screen doesn't want to scroll. I think my Surface is just mad at me. Okay, there. All right. Pick a point in each region and test it in the system of inequalities. Shade any regions that contain solutions to both inequalities. How many regions make up the solution to the system? So they want us to test a point here, 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 and here in each of the regions to see where the solution region is, but I'm going to do this a little differently. Why don't we just take the original inequalities and test points like we've been doing? So, oh my gosh, zoomed out too far. Okay, so here were the 2 original inequalities. Y is less than or equal to x squared plus x minus 6, and y is greater than 2/3 x. Let's test points and see where we're going to shade. So for this parabola, I can test a point on the inside of the parabola or on the outside. Let's pick one on the inside. Let's pick 0, 4. So that means that in my original inequality, I'm going to plug in 0 for x and 4 for y. So that would be 4 for y, 0 for x, 0 squared plus 0 minus 6. Let's see. Simplify. This is 0, that's 0. I'm left with negative 6. Is 4 less than or equal to negative 6? No. So 0, 4 is not a solution, and so therefore I am going to shade not on the inside of the parabola, but on the outside. all on the outside. Okay? I don't really like how I shaded that. Okay. Now let's test a point for the line and see where we're going to shade. Let's pick 0, 4 again. So test 0, 4. Again, we're going to plug in 4 for y and 0 for x. So 4 for y greater than 2/3 times 0. Let's see. 2/3 times 0 is 0. Is 4 greater than 0? It is. So for this line, okay, this dashed line, I am going to shade above it. Like this. Okay, maybe let's pick a different color because you can't really see the overlap. Let's pick this bright blue. Okay, really? We're not going to see it overlap? How weird. You can't really see it, but I hope you can tell that because we have a blue and green in this corner, this is a solution region. And because we have blue and green in this corner as well, this is also a solution region. So in this case, how many regions make up the solution to this system? 2 regions. Part D says, and you may have noticed that I didn't use 0, 0. Why is 0, 0 not a good point to use to test for this solution? Because 0, 0 falls on this boundary line, and that's why we don't want to use it. The boundary line in this case is dashed, which means that it's not part of the solution, which means why test 0, 0 if it's not going to work. So because 0, 0 falls on a boundary line. Okay, and we don't want to test points that falls. My grammar was wrong there. We don't want to test points that fall on a boundary line or a boundary parabola because they don't tell us anything about which side to shade. All right. Next problem. 9-92. How does changing the inequality affect the solution graph? Notice that each system of inequalities below uses the same boundary graphs as Reina's graph from problem 9-91. However, notice that this time the constraints are slightly altered. Devise a method to determine which region or regions are solutions for each system. Shade the appropriate regions on your notebook. Make sure you're copying this down, guys. Notebook. All right, so same line and same parabola as we were working with before, just a few minor changes. And I'm going to use the same colors. Okay, notice that here for part A, the only difference is now we have greater than equal to for this quadratic inequality instead of less than or equal to. Okay, so if here we have less than or equal to, and here we have greater than or equal to, then that just changes where I'm shading. Instead of shading instead of shading below the parabola, I'm going to shade on the inside. Okay, I chose a little bit of a different shade of green in hopes that we can see the solution region a little bit better. But again, here we had less than or equal to, so we were shading on the outside. If the sign flips, then the side that we're shading also flips. Okay, but over here we still have greater than, or this linear inequality for the line. So down here, come on, scroll one note. Since it's still greater than, we're still going to shade above the line. So that'll be nice. Okay. I hope that makes sense, guys. If you have any questions, please send me an email. But yeah, so notice that now, instead of our solution regions being on these corners up here, now our solution region is here. Okay, where we have overlap. Okay, from part A to part B, this quadratic inequality is the same. Okay, it's still greater than or equal to, which means that we are going to shade on the inside again. Shade on the inside of the parabola. And what's different is we have, instead of having greater than, y is greater than 2/3 x, now we have y is less than 2/3 x. So this has flipped, which means that instead of shading above the dashed line, now we are going to shade below the dashed line. Like this. Okay, so now our solution region is right here. And then last but not least, let's see, our quadratic inequality has once again changed, has flipped symbols. So here we have greater than or equal to, but now we have less than or equal to. So instead of shading on the inside of the parabola, again, we're going to shade on the outside like we did in the previous problem in 9-91. So all on the outside here. And then this inequality for the linear inequality has stayed the same. It's still less than. Okay, less than. So just like we did in part B, we're going to shade below the line. Okay, below. So now my solution region is out here. Okay, so that's it. I didn't test any points here just because I was able to use clues from the previous problem to tell me where to shade. So if you do want to verify that all of these work, pick a point in the solution region, plug it in, make sure it works, okay? But typically we do have to test points. All right, 9-93. Last problem for today. The United Nations asked every nation to write constraints that best approximate its country's shape. The UN thinks this will help find each country's area. Honduras sent in its inequalities, but some of the information is unreadable. With your study team, determine the missing parts of the inequalities and rewrite them on your paper. So this came like this in the textbook. What we have to do is figure out what symbols go here. Is it less than or equal to? Is it greater than? Which direction? So notice that all of these lines, I'm going to highlight them briefly. If my highlighter button works. Highlight. I want yellow. Okay. All of these boundary lines, those correspond to these 5 inequalities. And since they're all solid lines, then all of these have to be greater than or equal to or less than or equal to. Okay, we don't have any dashed lines here, so no less than or greater than. So that makes things a little bit easier. A good strategy would be to pick a point in the solution region, plug it into the inequality, and then put in the symbol that works. Okay, so for example, if we start with this guy, actually no, before we do that, let's pick a point that makes all of the inequalities true. Lucky for us, good old 0, 0 is in the solution region. So that means that 0, 0 makes all of the inequalities true. Okay, so if we plug in 0, 0 into all of these, we'll be able to find the missing inequality symbol. Okay, I hope it'll make more sense once I start to do this. So let's pick the first one. Okay, y, and then blank. We don't know what the symbol is. X plus 3. I'm going to plug in 0 for x and 0 for y, and then fill in the missing inequality. It's either greater than or equal to, or less than or equal to. Okay, so if I plug in 0 for x and 0 for y, and I simplify, which one of these would make this true? Do I need less than or equal to make this a true statement, or do I need greater than or equal to? Well, 0 is less than or equal to 3. And so for this first inequality, we have less than or equal to. Okay, so this one is done. Our next inequality, didn't mean to erase that. Our next inequality is this one. It's got a y, and a 2. Okay, again, plug in 0 for x and 0 for y. We don't have an x here, so just plug in 0 for y, 0 and a 2. Which symbol would make this true? Less than or equal to, or greater than or equal to? Well, 0 is less than or equal to 2. So then this symbol goes here. Less than or equal to. And the y is kind of blurred out too. Now let's move on to this one. We've got y and then a missing inequality symbol, negative 2/3 x minus 1. Again, plug in 0, 0 and then fill in the correct inequality symbol. So plug in 0 for y, 0 for x, simplify. Negative 2/3 times 0 is 0, and 0 minus 1 is negative 1. So in this case, a greater than or equal to symbol would be appropriate since 0 is greater than or equal to negative 1. So that is what we are going to put here. All right, moving on to the next one. Here it looks like we just need a y-intercept instead of an inequality symbol. So let's look for the line that has a slope of positive 1/2. Since this has a positive slope, that means that we're looking for a line that's going quote unquote uphill. So it's either going to be this line or this line. Which one has a slope of 1/2? Well, that would be the one that's less steep. Okay, let's verify. If I draw a slope triangle, am I going up 1/2? I am. Up 1/2, yes. So what is the y-intercept here? That would be -1. So that's what I'm going to write here. And then for that last inequality, I'm going to do the same thing that I've been doing. Plug in 0, 0, and fill in with the correct inequality symbol. Simplify. This is 0 plus 4, that's 4. So in this case, another less than or equal to symbol would be appropriate since 0 is less than or equal to 4. So here we are going to write less than or equal to. That's it. We were working backwards here. So if you start with the graph and then you're making the inequality from there, you can test points to see what your inequality symbol should be. But if you're doing what we did up here, starting with the inequalities and then graphing, make sure that you're testing points to see where to shade. That's it. Please email me if you have any questions and have a great day.